Hello students, today we are going to take up the topic temperature coefficient, collision theory, activation energy, Arrhenius equation, molecularity, mechanism of a reaction. Under chapter number 4 chemical kinetics of class 2 chemistry. Let us start. So thought for the session is, wealth is what you have left when all of your money is gone. Roger Hamilton. So what is the meaning that knowledge, what you acquire, what you gather, that is the true wealth. So let us start the topic. So you will be able to explain about temperature coefficient, collision theory, activation energy, Arrhenius equation, molecularity and mechanism. So first start with temperature coefficient is the ratio of rate constant of reaction at two different temperatures separated by 10 degrees Celsius. Means to say that, as you know that temperature increases, the rate of reaction increases. Actually, what is increasing is K is increasing with temperature. Rate also, because rate depends on K also. So, K T plus 10 degrees Celsius. When K value, when temperature is like if 25 is there, 10 plus 25 plus 10, 35. K 35 divided by K 25. This is the meaning. Okay. So, and mostly this value will be greater than 1 and it ranges between 2 and 3. Collision theory. Basic points in collision theory are, when two reactants collide together, it brings the reaction. But all the collision may not be effective. So reaction occurs when the reactant molecule undergo collision with each other. The fraction of molecules having energy greater than threshold energy are responsible for a chemical reaction. If the energy of molecules are less than the threshold energy, the collision may not be effective. Okay, and if more fraction of molecules having energy greater than the threshold energy, then collision will be effective, and that only will result into chemical reaction. Similarly, third point is only those collisions are effective which have energy greater than threshold energy. That's one part I already discussed, and have proper orientation. Orientation means to say that, for example, you just imagine a situation where two cars are coming in opposite direction and they are striking with each other. That's one. And another situation is one car is following another car, and immediately the car ahead just put the brake down. So once brake is applied, the other car may hit. So that both situations you understand that where collision will be effective. So in the first case, like opposite moving, so the orientation should be proper. So now you may not be clear about the activation energy. Let us understand the concept of activation energy here. So see the graph. This is the graph between number of molecules. Number of means fraction of molecules, and this graph is energy. And you know that the molecules having certain energy, like this many molecules are having energy less. But as you go here forward, energy greater molecules, that is becoming lesser. So what is the meaning? Like this is the activation energy, means this is the energy which every molecule will possess. When temperature you are increasing the energy. And now this is the activation energy for that particular reaction. Now if temperature is more, the molecules, what will happen? The molecules will move this way. Means the fraction of molecules having energy greater than this. So it means this area under the curve, that represents the fraction of molecules having energy greater than the activation energy, because we have to concentrate on these molecules only, because these molecules are not resulting into an effective collision. These are ineffective collisions. So there is no meaning at all for a reaction resulting whatever the products will be formed. That does not depend on these things, but here it depends on the shaded portion. Now as the temperature increases, so I see this diagram, the same only, all this 100, 25 and 0. If you see 0 degrees Celsius, the fraction of molecules having greater than activation energy is less. But if you talk of 25, that is the blue portion plus green portion. And if you are talking of 100 degrees Celsius, then here blue, green and yellow. So now where the shaded portion is more in case of 100. It means to say that as the temperature increases, the fraction of molecules having energy greater than activation energy increases, which results into collisions, and that collisions are effective, and effective collision will bring about the chemical change. Okay, the same is case of probability. Probability of finding molecules at higher energy increases as the temperature increases. Okay, so thereby the concept is coming with the 10 degrees Celsius increase in temperature, rate of reaction becomes doubled. The concept is this only: as you are increasing the temperature, activation energy is increasing. The fraction of molecules having energy greater than activation energy increases. That's the reason that the reaction rate is increasing. Now we have to understand more about the activation energy. Now we have discussed about the collisions, effective collisions, orientation. Now let us say activation energy is what basically. This is an energy level diagram. This is energy versus the course of reaction. Y-axis energy and course of reaction. Now the reactant must be possessing some energy. Now for the reactant to convert into products, so sometime the curve would be the product energy is more and sometime the product energy is less. So in case of product energy is more, that type of reactions are called endothermic. And if product energy is less, that type of reactions are called exothermic. Means heat is released and the energy decreases. Heat is absorbed and the energy improved. Now you can see, now to go from reactant molecules to reach to the products, we need to cross this barrier. This is the barrier, and this barrier is called energy barrier. And the energy reactant molecules possess, that's one. And excess amount of energy which is required by the reactant molecule to cross this energy barrier is called activation energy. It means if you talk of total, like from starting from this 0 to this peak of the curve, that is known as threshold. And this energy is already possessed. It means activation energy is what? Activation energy is total, this total threshold minus the energy of reactant, that will give the activation energy. Wherever activation energy is more, it means that the product, the what actually basically catalyst, if you remember the catalyst, what is doing? Catalyst is doing what? That catalyst is just changing the path, like here it will move here. So what will happen? The activation energy will decrease. So the same manner the catalyst role is to decrease the activation energy. So what I want to say is the basic thing is the activation energy is the excess amount of energy required by the reactant molecules to cross the energy barrier. Similarly, if the reaction is exothermic, so the product will be here. Now energy of reactant was this. Now here, so it has to, we have to give once activation energy to start the reaction. Once the reaction is started, then it will continue working on as such. For example, in the case of nitrogen plus hydrogen give ammonia, that is exothermic reaction. But to start a reaction, we need to have some temperature like 450 to 500. After that, we have to remove the heat. So this is the basic concept for activation energy. We should keep in mind, and the energy level diagram also we should know how to draw it. Activation energy, it is defined as the excess amount. Sometimes students are forgetting this excess writing. This is very important. Excess amount of energy that reactant molecule must acquire in order to cross the energy barrier and to change it in product. So I think this is understood now. Activation energy, threshold minus average energy. As I told you already, this if you take from the ground 0 to the topmost, that is called threshold, and this is called the average energy of the reactant. If you total minus this, then it will be activation energy. This is the meaning of that statement. Threshold energy minus average energy possessed by the reactant molecule, that will give activation energy. So activation energy, if reaction is very slow, very fast, then reactions activation energy will be low. And if reactions are slow, it means activation energy are high. That is understood only. That slow reaction we need to give more temperature to increase their energy, and therefore activation energy will be more. Now next, this we have studied in part 1 also. This I am going into detail now. K is equal to A e raised to power minus EA by RT. This is Arrhenius equation. This is the first form. Arrhenius equation having 3 forms. So first we are discussing now. K is rate constant. You know already K depends on temperature. And A is pre-exponential factor, or is known as frequency factor also, that we are going to discuss next. E is this base of natural logarithm. E raised to power EA. EA is activation energy. Basically A we are not writing capital. E small subscript will be small a. Activation energy RT. R is gas constant. In this case R value should be 8.314. Please don't forget that 0.082 you should not use, because that was used for pressure terms. This is energy terms, and temperature should be in Kelvin only. If you put substitution, if you substitute in Celsius, then your numerical will be wrong. Now as earlier I was telling you that A is exponential factor or frequency factor also we are saying. So this factor depends on two further factors, that is called collision frequency and probability factor. Collision frequency definition also can be asked, number of factor collision per unit volume per unit second. This is the definition. Sometimes students are writing collision number of factor collision per unit volume. This is all. No, it's not like that. Number of factor collision per unit volume per unit second. That has to get right. Probability factor. Probability of factor collision depends on the steric factor orientation. Steric orientation, that I just now make you clear that regarding taking the example of two cars. So the orientation of the reacting molecule will decide. Like for example, negative ion if approaching each other, the orientation is not correct. If positive negative is striking each other, then orientation will be good. So this is way. Like sometimes bulkier group, more you will understand this is an organic chemistry mechanisms. So when steric hindrance means bulky group is attached with the carbon, like let us say 3 degree carbon and 1 degree carbon, which will be more reactive. So if for a nucleophilic substitution action. So this all these things we will discuss more in the mechanism in +2. Okay, probability of steric hindrance factor. If you are not understood the steric means that area is surrounding area is closed for any attack for the nucleophile electrophile. Okay, so now as I earlier told you that this is the forms of Arrhenius equation. This first form was K is equal to e raised to minus EA by RT. Now it's the second form, K is equal to A e raised to. Now taking the natural log, we are getting this equation. This is the second form of equation. Now in this equation, natural log K is there. If natural log you want to change into log, means base 10, log K is equal to minus EA by 2.303 will come along with that, nothing else. Plus log A will come here. So this is already clear. This is a straight line equation, y and x. This is y. This is m minus EA by r is m slope, and 1 by t is x, and plus c is intercept. This natural log A is the intercept, and y natural log K, and x 1 by t, and slope is minus EA by r. If you are taking log here, then slope would be minus EA by 2.303 r. This is only the difference. So let us do one numerical on this equation. That was the third form of this equation. As earlier I told you, there are 3 forms of Arrhenius equation. This is the relative form, means 2 forms are there. Actually one and the same thing, only just they have used for the formula. Previously the same. This is log, if you put 2 times then minus it, then this equation will come. Next one, log K2 by K1 EA by 2.303 R 1 by T1 minus 1 by T2. Please don't use the formula which is given in the book. Sometimes they are using K1, K2 and minus here. Always there is a chance of error. So you make a habit of using this formula only. So there won't be any confusion, there won't be any error in your answers. Okay. So here most important point I want to tell you is that temperature should be in Kelvin. So don't put temperature in Celsius. You will not get any mark. So 20 change to 293 and 50 to 323, and accordingly substitute K2 by K1. Rate of reaction triples. Rate of reaction triple means K2 by K1 is 3 times, because here we are considering that concentration is same, only temperature are being changed. So that's why we are not taking any concentration terms. K2 by K1 is 3, and substituting EA you will get this value 28. So answer would come in joule per mole. So to convert into kilojoule we have to divide by 1000. This also we have to keep in mind. Okay. Next numerical is regarding to the graph. Slope of the line in the graph of log K. Previously I told you this equation was given, natural log A and 1 by T, but this is log. So if log is there, only thing difference is minus EA by 2.303 will be there. So here minus 2.303. This is the graph. Y is equal to m, x and c. M is minus EA by 2.303 r. This is the slope, minus EA by 2.303 r. So this is given, slope is given. So r multiplied, r value I told you already 8.314 joule per mole only. This is the overall answer, units for activation energy. And if you want to convert into kilojoule, you have to divide by 1000. So hopefully this is understood. These are the 2 very good numericals. It can be asked in the exams. Next is molecularity. Molecularity of an elementary reaction is equal to the number of reacting species, whether atoms or ions or molecules, as it is represented by the balanced chemical equation of the reaction. If reaction is balanced, number of reacting species colliding together simultaneously. This word is very, very important. We should keep in mind that simultaneously word. Here also is definition I have missed here. So number of molecules at required number of reacting species reacting simultaneously word we should focus. Simultaneously word is important and it should be must in the definition of molecularity. Elementary reactions which are simple. So two types of reactions are there: elementary and non-elementary. Elementary means which happen in one step. Okay, and non-elementary reaction which are complex. Complex means it may be there in the series of steps, 1 step, 2 step, 3 step, like this manner. So now molecularity is a theoretical concept. It's not a this practical or experimental concept. Molecularity cannot be zero. Earlier we have discussed that order can be zero, negative, positive, but here it will be always positive. It cannot be in fraction. It cannot be zero. It cannot be negative. Okay, and this is theoretical concept. Molecularity cannot be greater than 3 because you see, have you seen that the 4 cars colliding simultaneously? So that's why this concept is that 4 molecules coming from different direction colliding at the same point, the probability is very less. So that's why saying molecularity cannot be greater than 3 because more than 3 molecules may not mutually collide. So this mutual word is important. So that's what I was using simultaneously, this mutual. So this part you should be very clear and you should introduce this word in the definition. Now here these are some examples. You can see one is molecule, so unimolecular. Uni means 1 and 2 are there, y, and 3, 2 plus 1, 3, y, 1 plus 1, 2. So 2 plus 1, 3 and 2 plus 1, 3. So this is the molecularity of reactions. Now here also same thing, only the both rate law also is given. Rate law is A raised to power 1 or rate law. Order is 1, order is 2, order 1 plus 1, 2, order is 3, 2 plus 1, 3, 1 plus 1, 1, 3. Order and molecularity may be same and it may be different also sometimes. Okay, so we cannot say that. So molecularity order we have already discussed that. See here simultaneously word is added. It is the number of reacting species which collide simultaneously to bring about the chemical change. Simultaneous word is very important. Some of the powers with the concentration terms of reactants are raised in a rate law expression. It can have only positive values, no negative, no zero. And here can be zero, negative or fraction. Molecularity is a theoretical concept. It is experimental concept. Okay, and these are further examples where order and molecularity is given. So as you see here, order and molecularities are same, but see the fifth example. RCl plus water give rise to molecularity is 2 but order is 1. So similarly this also hydrolysis of ester, pseudo first order reaction. So order is 1, molecularity is 2. Okay. Next, pseudo unimolecular reaction. The first order reactions having molecularity greater than 1 are called pseudo unimolecular reactions. So in this case you see that the order is 1. Why 1? Because this is excess. This is taken in excess. And you know that excess reactant is not governing the rate of reaction, limiting is governing. So that's why the order is 1 and H2O was there earlier but it was made 0. Why? Because it is present in large excess. Now in this case molecularity is 2. Pseudo unimolecular reactions having molecularity greater than 1 are called pseudo unimolecular. So it seems that its order is 1 but molecularity is 2. Okay. Next is this mechanism. So this is one of the important topic. You should understand it properly, and it's very easy, not much difficult, but seems to be difficult. It's also like pseudo, seeming like difficult, but actually it is easy. How? Let us see. Sequence of intermediate steps or elementary processes proposed to account for the overall stoichiometry of a reaction is called the mechanism of the reaction. So mechanism means this reactant are converted to product. How? Which way, which intermediates are formed, and which is the steps being followed for a reaction, sequence of steps. Okay, and for example complex reaction is there or non-elementary reaction is there, that also will be having number of steps. So each step we will see that which step is the slowest step. So as per the slowest step our rate will depend on the slowest step. Okay, next is simple reaction can occur in a single step, whereas complex reaction takes place in a series of steps which involving 1, 2 or at the most 3 molecules. That means to say that molecularity is 1, 2 or maximum 3. Next, so this is the question. I will take up the question and I will make the concept clear. What is the rate of reaction and the order of reaction of the mechanism? Now mechanism has been given to you. They are asking what is the order and order of the reaction. and rate of reaction. Now see, you should see that this thing information we should have, which is slow, which is fast. Before that we cannot do anything. So slow reaction only rate determining step. We know that limiting reagent concept also we studied in +1. So limiting reagent is deciding the product. Okay. So in this way, slow reaction will govern the rate of reaction. So rate of reaction will be rate is equal to K NO raised to the power 2 and hydrogen raised to the power 1. So overall order is 3. So we are not taking the second equation. Why? Because if first equation will not complete, then how second will form? So as soon as N2 will be formed, that only then H2O2 will be formed, then only further reaction will take place. This is the meaning. Okay. So next question. This is different approach. Here they have given that a mechanism is given. So you just rate law is given and equation is given. Find out the mechanism. Now basic thing is this information we should have, the main thing. So now from this we come to know that NO2 is deciding the reaction rate, and it means this reaction is non-elementary. So we have to split this reaction into number of steps. So first step is we split it as per this ki NO2 plus NO2 give rise to what? NO plus NO3. So one of the product we taken and one intermediate taken. One of the product, because two products were there, one of the product taken, here NO taken and one intermediate. Now that intermediate again react with the second reactant and give the product and the excess reactant. We have used excess reactant here and not so we have here. So if you add these two reactions, it will come same. So means to say that as per this order is this second order, we have just thought of that slowest reaction might be there where the two molecules might be reacting NO2. So that's why it leads to the formation of the slowest step reaction. So after slowest step reaction we can go for the next, because by adding these two reactions we should get this. Okay. So and this is derived now, rate is equal to K NO2 raised to power 2, order is 2. Let us try one more. Mechanism of the reaction where rate is given. Here rate is given, this equation is given, we have to find mechanism. Now you see the rate depends on NO2 and hydrogen. It means your equation will be divided now. I think this is NO is there. Okay, see here hydrogen, yes, fine. This equation is given, correct. Now what we are doing is we are taking one reactant to NO and here actually this is NO, not 2, NO. So NO is taken and hydrogen. So 2 NO, so it is NO only, KNO raised to power 2 plus hydrogen raised to power 1. This is okay. Slow step is giving one of the product, one intermediate, and that intermediate react with another reactant to give the product, which is here. So these two reactions, thereby we can form the mechanism. Nothing else is there. This is very easy. See, these two reactions we have made. Only thing we have to check thoroughly that what is the rate law equation. Accordingly with this, because this is coming from experiment data. Okay. Now this let us have the recap. Temperature coefficient is the ratio of rate constant of reaction at two different temperatures separated by 10 degrees Celsius. Collision theory says that reaction occurs due to fractal collision, and those collisions are fractal those who are having energy greater than activation energy and have proper orientation. And activation energy is the excess energy required by the reactant molecule to cross the energy barrier. Arrhenius question explains the variation of rate constant with respect to temperature. Three different forms of Arrhenius equation we have studied. Molecularity is number of reacting molecules which must be colliding simultaneously. That word is very important. Slowest step is the rate determining step. Pseudo unimolecular reactions are having molecularity greater than 1 are called pseudo unimolecular reactions. Okay, so let us see the thought once more. Wealth is what you have left when all of your money is gone. Okay, thank you very much.